Last example is exponential decay. So it says if a radioactive material has a half-life of 10,250 years, how long will it take for 10 grams of the substance to decay to 2 grams? So we did these before with a base B or base A. Here we're going to use a base E just to show you a different way to do this. On your homework, you can do it either way. So A of t equals A sub naught e to the minus kt. So the minus is because it's decay. The k is a positive constant. And this is a different way of doing it rather than writing just b to the t. Here, your constant of decay is the k. And this is more common than using the a sub naught a to the t. It's more commonly how it does. And that's because you can apply calculus to this to find the rates of change really easily. So I put in my numbers. I started with 10. I end up, in a half-life, I end up with 5. So 5 equals 10 e to the minus k. In 10,000, you get half as much in 10,250 years. So this is just to figure out what k is. That gives me that 1/2 equals e to the minus k times 10,250. I did ln of both sides to get rid of the e on the right-hand side. And I get ln of 0.5 equals negative 10,250k. And you divide that out. And I just stored that in memory. I use store alpha k. So that just stores it in memory k, since it's the letter k. Okay, now I go back to my original formula, but the k, I'm going to use this number that I have in memory. So I can just type it out with the letter k there, and it'll put in the number. So the rest of the problem says, how long will it take for 10 grams of the substance to decay to 2 grams? So again, I have 10 grams is my initial amount, but my final amount, instead of being 5, will be 2 grams. So I type that out. That gives me, 0.2 e to the minus kt, ln of both sides. Right? ln and the e cancel. ln 0.2 equals minus kt. Remember, minus k, I already know what that is, so I need to divide by that. And then I just type that out on my calculator. ln of 0.2 divided by negative, and then I do the alpha k. So it'll actually put a k there. And that puts the number that's stored in k in there. And I get t is approximately 23,800 years. Now, does that make sense? Well, it takes about 10,000 years to go to 5, and then it's a little more than half again, so a little more than 20,000 years makes total sense. So that's kind of what I did, right? 2.5 and 2000, right? But we want less than 2.5, so you need more than 20,000. So that seems about right. So I'm checking it for reasonableness or plausibility. And that's it with that section. So you're just solving various types of problems that using logarithms and exponential functions combined.